want to go over the problems from week 3 out of sections 1.4, 1.5, and 1.6. So we're going to start in section 1.4 here on page 214, doing problem number 34. Problem number 34 asks us to use the given conditions to write an equation for each line in point-slope form and slope-intercept form. In number 34, we're just given 2 points and told the line passes through those 2 points. I'll write them here on the board and then we'll get started. So in number 34, our 2 points are -2 minus 5 and 6 minus 5. So we're asked to write the equation of the line in 2 different formats. First in point-slope form and then in slope-intercept form. Any way I was to get started, I would need to first find the slope. So that's what we're going to do first. We're going to find the slope of this line. y2 minus y1. If we stopped right here, we probably know what's going on. 6 minus a minus 2. Well, on top, I really have minus 5 plus 5. On the bottom, I have 8. So I have 0 over 8, which of course is 0. So we're going to have a slope of 0. Right away, this tells me that this is the equation, going to be the equation of a horizontal line. Because horizontal lines are lines with no slope. Well, to follow directions, I'm going to write this down in point-slope form. So I pick one of the points, and it doesn't matter which one. I'm going to pick the first one. Y minus a minus 5, so y plus 5 equals the slope times x minus a minus 2, so x plus 2. That is point-slope form. And slope-intercept form, I need to get y by itself. So I have y plus 5, and 0 times anything is just 0. Take 5 away from both sides, and I get y equals minus 5. And in my handwritten solutions that are linked to our Moodle course, you'll see that I made a little note that horizontal lines always have this format. They're always in the format of y equals a constant, right? Because our horizontal lines have that property that y is always the same number. 1, 2, 3, 4, 5. So I get y equals minus 5, all the points down there with a y value of minus 5. All right, so there's 34. Next up, I wanted to do problem number 64. In number 64, we're given the equation of a line in its standard form. We're asked to rewrite it in its slope-intercept form. We're asked to state the slope and y-intercept, and then finally to graph the linear function given that information. So to start off here in number 64, we're given the line 6x minus 5y minus 20 equals 0. And we're asked to put this in slope-intercept form, and to me that always just means get y by itself. I'm going to choose to add 5y to both sides, which would mean 5y is equal to 6x minus 20. To get the y by itself, I just need to divide by 5. So here's the slope-intercept form of the line. That's my answer to part A. In part B, I'm asked simply to write down the slope and the y-intercept. So the slope, 6 over 5. And then the y-intercept, I like to write down a point. So I'm going to get 0 comma minus 4. Finally, we're asked to graph that line. And just to summarize what we just wrote in part B, we had a slope of 6/5 and a y-intercept of 0 minus 4. And that's all I need to know to graph this line. I plot the y-intercept, and then I need to use the slope to find another point on the line. So I'm going to go up 6, 1, 2, 3, 4, 5, 6, and over 5. 1, 2, 3, 4, 5. And a straight line connects those two things. In my handwritten solutions, I've done a good job and used a ruler. Those are nice solutions you can look at. For right now, I'll just freehand the best line I can, and unfortunately, that's the best line I can. But that's the line that we started with. 6x minus 5y minus 20 equals 0. And in the slope-intercept form, we had 6/5 x minus 4. All right, so that's number 64. Next up, we were asked to do number 72. Number 72 again gives me a line in its general form, and this time asks me to graph it using its intercepts. So I'm going to find both the x and the y intercepts this time. I almost wrote the problem down wrong. 6x minus 3y plus 15 equals 0. So this time we're asked to graph that line by finding its intercepts. So I remember that if I want to find an x-intercept, I plug 0 in for y. Well, 3 times 0 is 0, so I just really have 6x plus 15 is equal to 0. Take 15 away from both sides, divide by 6, and I'll find the location of that x-intercept. I should reduce that fraction. I get minus 5 over 2. So my x-intercept is the point minus 5 over 2 comma 0. I plug 0 in for y, and I found what x was equal to. So there's my x-intercept. For the y-intercept, I plug 0 in for x. So I have 6 times 0 minus 3y plus 15. Well, 0 times anything is 0, so I have minus 3y plus 15 equals 0. I'll take 15 away from both sides. Get minus 3y equals minus 15. Divide everything by minus 3. And it tells me y is 5. So my y-intercept, well, when x was 0, y is 5. That gives me 2 nice happy points to graph my straight line with. It's special that they're intercepts. The intercepts are always pretty easy to find. But the fact I have 2 points on this line is enough to graph it, no matter what kind of points they were. All right, I'll plot my 2 points. Minus 5 over 2, so minus 2.5. 1, 2, and half. Right there on the x-axis, 0, 5. 1, 2, 3, 4, 5. Nice happy straight line. And again, my handwritten solutions have a nice straight line. I even used a ruler and everything. It's a very nice graph. That gets us through the problems in section 1.4 that I wanted to do. So in the next video, I'll do the problems from section 1.5.